Hi everyone. Today we're going to master one of the most important building blocks in all of algebra, linear equations. By the end of this lesson, you'll be able to spot one, classify it, solve it even when it looks scary with fractions everywhere, and graph it with confidence. Let's get started. Here's our roadmap for today. We'll start from the very top, what an equation even is, and work our way down step by step until we're solving real problems and drawing real graphs. Don't worry about memorizing this list right now. Just know that everything builds on the thing before it. Let's dive in. First thing first, what exactly is an equation? An equation is a mathematical statement that says two expressions are equal, connected by that little equal sign. Notice three things about that. First, it always has an equal sign. That's non-negotiable. Without it, it's not an equation. Second, it's making a claim. That claim can be true or it can be false, depending on what number we plug in. And third, because it makes a claim, we can actually solve it. We can hunt for the value that makes the claim true. Look at this example. 2x plus 3 equals 7. This is saying that there is some number x, and when you double it and add 3, you get 7. Our job now is to go find that number. Let's talk about equation versus expression. Here's something students mix up all the time, the difference between an equation and an expression. A mathematical expression is just a combination of numbers, variables, and operations, but with no equal sign. It's not making any claim at all. Let's build this comparison together. No equal sign versus has an equal sign. Because there's no equal sign, you can solve an expression. There's nothing to solve for. But an equation, absolutely, you can solve it. An expression, you can only simplify or evaluate. An equation has an actual truth value. It's either true or false. So 2x plus 3, that's an expression, just sitting there. But 2x plus 3 equals 7, now that's an equation making a claim we can test. Keep that distinction in your pocket. It will save you from a lot of confusion later. Again, this is an expression and this is an equation. Equations actually come in a whole family of types. Let's zoom out and see the big picture. Don't worry, we're not solving all of this today. I just want you to know they exist. At the very top, we have equations in general. They split into two major branches. First is algebraic equations. These are built using ordinary operations like addition, subtraction, multiplication, division, and roots or powers of the variable. The second one is what we call transcendental equations. These involve things like sine, cosine, exponentials, or logarithms, functions that go beyond basic algebra. Okay, and transcendental equation is also known as non-algebraic equations. An algebraic equation looks like this: x squared plus 3x plus 2 equals 0. Everything here is polynomial style algebra. A transcendental function, such as this one, sine x is equal to 1 half or e raised to x equals 5. You'll meet this in trigonometry and pre-calculus. Today, we're staying entirely inside the algebraic branch. Let's zoom in one more level into algebraic equations specifically. Algebraic equations branch into three types. The first one is what we call polynomial equation. The second one is rational equation. And the third one is radical equation. First, polynomial equation. Polynomial equation built purely from the whole number powers of the variable. No fractions with x on the bottom, no roots, and so on and so forth. Example, x squared plus 3x plus 2 is equal to 0. Next, rational equation contains a fraction with a variable in the denominator. For example, x plus 1 all over x minus 2 is equal to 3. And lastly, radical equation contains the variable inside a root called a radical. For example, square root of x plus 3 is equal to 5. We're going to zoom into that first branch, polynomial equations, because that's where linear equations live. Polynomial equations themselves are classified by something called their degree. So we will be talking about the types of polynomial equations considering the degree of that specific equation. Linear looks like ax plus b equals 0. So a linear equation is an equation in degree 1. This is how it looks like. We have the second one, quadratic. Quadratic equation is a polynomial equation in degree 2. It looks like ax squared plus bx plus c is equal to 0. Also, we have cubic. Cubic equation is an equation in degree 3. This is how it looks like. Ax cubed plus bx squared plus cx plus d is equal to 0. Our focus for the rest of this presentation is about linear equations. Good to know that it exists, the quadratic, cubic, and also we have quartic, quintic, and n-degree polynomial equations. Okay, now, so let's proceed to the definition of a linear equation. Let's really define what a linear equation is. A linear equation is a polynomial equation of degree 1. The variable shows up only to the first power. Again, no squares, no roots, no variable is stuck in a denominator. In one variable, the general form ax plus b equals 0, where a can't be 0, because if a were 0, the x would vanish and it would not be an equation with a variable anymore. In two variables, like we have variable x and y, it looks like ax plus by equals c. This is the form you'll use later for graphing. A few defining traits to lock in: its graph is always a perfectly straight line. That's actually why it's called linear. So it can be increasing or decreasing. The exponent on the variable is always exactly 1. And you will never see products of variables like xy, never an x squared, never a square root of x, never a variable in the bottom of a fraction. If you see any of those, it's not linear. It's automatically nonlinear. Let's put that definition to work. First, 2x plus 5 equals 9. We have linear. So why is it a linear equation? What are the things that we must consider? First, understand that a linear equation is in degree 1, or a polynomial equation in degree 1. Since we have just 2x here, it means that we have an invisible 1 as an exponent of x, and we have no other x's or variables here. Therefore, the highest exponent is 1, then the degree is 1. Therefore, it is considered a linear equation. Next, the second one is x squared minus 4 equals 0. Is it a linear equation? The answer is no. Automatically, because we can see an x squared here. Therefore, it's called the quadratic. How about 3x minus 2y equals 6? Is it a linear equation? It is a linear equation, but in two variables. It means that we have first variable x in degree 1, second variable y also in degree 1. Therefore, we have no problem with that. It is a linear equation in two variables. Next, 1 over x plus 2 is equal to 5. It is not a linear equation. Let's plug 1 over x. 1 over x has a variable in the denominator. Therefore, it is considered a rational equation. Square root of x plus 1 is equal to 4. It is generally not a linear equation because we have a square root of x here, which represents a radical expression. And when we make it as an equation, it is called a radical equation. And lastly, 5x minus 7 equals 2x plus 1. There are lots of things that we can do here to solve for the value of x. But yes, it is a linear equation. Notice the pattern. It's not about how long or messy the equation looks. It's purely about whether the variable's power is exactly 1. Now, here's something a lot of courses skip, but it's really important. Not every linear equation behaves the same way when you solve it. There are actually three personalities a linear equation can have. Let's meet the first one. An identity or identity linear equation is an equation that's true for every single value you could plug in, considering that we are in real numbers. When you simplify it all the way down, you land on something like 6 equals 6, a statement that's always true no matter what. For example, let's solve this one together. 2 times the quantity of x plus 3 equals to x plus 6. Okay? First thing that we must do here is to distribute the left side. That gives us 2x plus 6 equals to x plus 6. So from here, we can see that we have same expressions showing on the left-hand side and the right-hand side of the equation. Subtracting 2x from both sides, minus 2x, and another minus 2x, gives us 6 equals 6. Subtracting 6 from both sides can also gives us 0 equals 0. If ever you're solving a linear equation and you come in this form, understand that it is a type of equation called identity linear equation. Since 6 equals 6 or 0 equals 0 is always true, every real number is a solution. It means that if I substitute 0, the equation will be true. 2 times 0 plus 3 is 2 times 3. 2 times 0 plus 6. 2 times 3 is equal to 6. And 2 times 0 is equal to 6 as well. So this is true. It means that x can be 0. Next, how about if x is equal to 1? If x is equal to 1, 2 times 1 plus 3 is equal to 2 times 1 plus 6. So we have 2 times 4 equals 2 plus 6. Therefore, we have 8 is equal to 8. And also 2. And also 3. And 4. And so on and so forth. And even negative numbers. We can also substitute negative numbers and the equation will stay true. So, this kind of equation or linear equation is called an identity equation if all the real number or every real number is a solution. Solution is a term that we will be using for the value of x that we solved. Okay? Now, next personality, the conditional equation. what are the conditional equation, or what is a conditional equation? And honestly, this is the type you'll meet 90% of the time. A conditional equation is only true for one specific value, or maybe a couple of specific values, not for everything. Example, 2x plus 5 is equal to 13. Subtract 5 from both sides. So subtract 5 from both sides. 2x plus 5 minus 5, it becomes 2x. 13 minus 5 is equal to 8. So we have now 2x is equal to 8. And then divide both sides by 2. That gives us x is equal to 4. This equation is only true when x is exactly 4. Plug in x equals 5 and it breaks. Plug in x equals 0, it breaks. Only x equals 4 works. That condition is what makes it conditional. So again, please remember, when we say conditional, we found a specific value of x, which make the equation true. And the third personality, the one that trips students up the most, the inconsistent equation. What is inconsistent equation? This is an equation that is never true, no matter what you plug in. When you simplify, you land on something false, like 5 equals 9. Example, x plus 5 is equal to x plus 9. Subtract x from both sides, which gives us 5 is equal to 9. Since 5 is not equal to 9 and 5 equals 9 is false, there is no value of x that works. This equation is inconsistent. As a review again, when we say identity, the solution or the last number that you can see on your computation is a number that is equal to itself. For example, 6 equals 6, 0 equals 0. And it means that the solution is every real number. Next, conditional. There is a specific value of x that will make the equation true. Next, this one or the third one is inconsistent because in your computation, you found an inconsistent statement. 5 equals 9 is inconsistent statement. Why? Because it is not equal. Okay? So what is the solution of this inconsistent linear equation? The solution here is a null set. Null set. It means that we have no solution. There is no value of x that works. Right? So those are the three personalities of linear equations, or the types of linear equations. Again, we have first identity, second conditional, and third inconsistent. Now, we are ready for time to practice. I'm going to walk you through 5 problems, from simple to seriously fraction heavy. Grab a pencil and try to solve alongside me before each step reveals. Problem 1. 2x plus 5 equals 13. Step 1 that you must do here is subtract 5 both sides. Subtract 5 here, subtract 5 here. So if we have 2x plus 5 equals 13, remember that in solving linear equation or solving a specific equation, your target is to isolate x. It means that there must be no number beside it, or there is no number added to it, subtracted to it, divided to it. Just make this equation x equals a specific number. And so with that, if you have 2x plus 5 equals 13, the first step that you must do is to erase this plus 5 on the left side. Okay, but you may have x on the left or even on the right side. It's up to you. But in this case, it is obviously best to have x on the left side. So again, the first thing that we must do here is to subtract 5 both sides. 2x plus 5 and then minus 5. So we can cancel positive 5 and negative 5 because that's equal to 0. What's remaining here is 2x equals 8. And of course, we need to simplify 2x equals 8 by dividing both sides by 2. And therefore, we have x is equal to 4. Therefore, this is a conditional linear equation because this equation can be true if x is equal to 4. Let's check. 2 times 4 plus 5 is equal or not to 13. 8 plus 5 is equal or not to 13. 8 plus 5 is 13 equals 13. Therefore, this equation is true if x is equal to 4. Let's talk about the second problem. 3 times the quantity of x minus 4 equals 2x minus 5. The best thing that you must do here is first distribute this 3 to both of x and negative 4. Remember that we are considering the proper arrangement of operations called the GEMDAS rule. GEMDAS means grouping symbol, including the parentheses, bracket, or braces, or anything that we can use as a grouping symbol. And then E represents exponent. So since we have no exponent here other than 1 because it's a linear equation, we can proceed to MD. MD, M represents multiplication and D represents division. Remember that it is interchangeable. Whichever comes first, that would be the first operation that you must use. So if division comes first, you must divide it first before multiplying. Okay? So they are interchangeable. Same with AS, which is addition and subtraction. Whichever comes first. If subtraction comes first, then do it first before addition. But if addition comes first, do it first before subtraction. Now, if we have 3 times x minus 4 equals to x minus 5, the first thing that we must do here is the multiplication or distributive property of multiplication. Multiply 3 to x, that gives us 3x, and multiply 3 to negative 4 is negative 12. And that's equal to 2x minus 5. Just copy it, 2x minus 5. And then we'll need to simplify this. We need to combine like terms, and to combine like terms again, your target is to isolate x. Therefore, we need to move every term with x to a specific place. So if we want to move every x to the left side, then we must let this 2x be out of this right side. So in order for us to do that, we may subtract 2x both sides. Subtract 2x both sides. That gives us 3x minus 2x is equal to x. Then copy negative 12 equals to x minus 2x is cancelled because that's 0. Minus 5. Copy the minus 5. And again, our target here is to isolate x. Therefore, we must also remove negative 12 here on the left side. And for us to do that, just add 12. Remember, if it's subtracted, we can neutralize it using plus 12. That gives us x, copy x, and then negative 12 plus 12 is equal to 0, so we can cancel it out. Negative 5 plus 12 is positive 7. Therefore, this is another conditional expression, conditional equation, should I say, conditional equation, since this equation is true only for x equals 7. Other than that, it is not it will not be equal. If we use x equals 6, 0, 2, 1, negative numbers, and so on and so forth, it will not be equal. But if we use x equals 7, Okay, this equation will be equal or will be true. 5x plus 2 is equal to 5x minus 3. Let's start by again make sure that every x here is located in just one place. We must combine like terms. And every constant term here or a term without the variable x must be also in a specific place where the variable x is not there. So in this case, we can subtract 5x both sides. For us to remove this 5x, 5x minus 5x is equal to 0. So bring down positive 2. 5x minus 5x is also equal to 0. Then bring down negative 3. And 2 is not equal to negative 3. So this is an inconsistent equation. Therefore, the solution must be a null set. Or you may represent it using this. In words, no solution. Okay, so that's how we solve this practice problem number 3. 4 times the quantity of x plus 2 is equal to 4x plus 8. Again, the first thing that we must do here is to distribute this 4 to x and then positive 2. Now we have 4x plus 8 equals 4x plus 8. We can see a pattern here. The left-hand side expression is the same representation or is the same representation that we can see here in the right side of the equation. So let's proceed. Our target here is to make this 4x disappear from the right hand side. So subtract both sides to 4x. Remember, whatever you do to the left side of the equation, you must also do it to the right side of the equation because that is the essence of an equation. 4x minus 4x is 0 and then copy 8. 4x minus 4x is also equal to 0, then copy the remaining 8. That gives us 8 equals 8. Or also, if we subtract 8 from both sides, that gives us 0 equals 0. And again, this is a clue that this is a type of linear equation called identity linear equation. When we say identity linear equation, every real number is a solution to this equation. It means that we can substitute 2, 3, 4, 5, negative 7, negative 100 to make this equation true. So our solution here is we can represent it as negative infinity to positive infinity. This represents the set of whole numbers or real numbers. Okay, let's proceed to practice problem number 5. It is more complex than the previous examples. We have 1/2 times the quantity of 2/3 x plus 4 plus 5 equals 1/6 times the quantity of 3x plus 2 minus 2x. Okay, so what is the first thing that we must do here? Remember that we are in the rule of GEMDAS. First is you need to simplify everything that you can simplify inside the grouping symbol, such as parentheses. Since we can't combine 2/3 x to 4 or 3x plus 2, we can now proceed to the exponent. Since this is a linear equation and we can see an exponent which is an invisible exponent that is raised to 1, therefore, we can proceed to the arithmetic operations, multiplication and division, whichever comes first. In this case, we have 1/2 multiplied to this quantity, therefore we can distribute it. Also, 1/6 multiplied to this quantity That is also multiplication. So we can start by expanding that. So let's use this part as our scratch for solutions. So if we have 1/2 times 2/3 x, remember that if we want to multiply fraction to another fraction, what we need to do here is to multiply directly their numerators and also their denominators. 1 times 2 is equal to 2, and 2 times 3 is equal to 6. Then copy x. And if you want to simplify it, think of a number that you can divide to both of 2 and 6. So they are both divisible to 2. 2 divided by 2 is equal to 1, and 6 divided by 2 is equal to 3. Therefore, 2 6 is simplified as 1/3, then copy x. The first multiplication is equal to 1/3 x. Next, if we want to multiply 1/2 to a whole number 4, please review that the process that we do here is to make the whole number 4 becomes a fraction. Just add over 1. Just write over 1 here and then multiply directly again. 1 times 4 is equal to 4. And then 2 times 1 is equal to 2. And 4 divided by 2 is equal to 2. That gives us the answer to the second distribution. Now we have 1/3 x. The answer for the first multiplication, 1/3 x, plus 1/2 times 4 is 2. And then just copy the unaffected number, which is plus 5. Equals, also let's solve for 1 over 6 times the quantity of 3x plus 2. We have 1 6 multiplied to 3x first. So again, the first thing that we must do here is to put over 1, then multiply directly the numerators and denominators. 1 times 3x is 3x. 6 times 1 is equal to 6. And then we can divide it both sides by 3 to simplify it. So we have now 3 divided by 3 is equal to 1. And since we have x, just copy x. Then 6 divided by 3 is equal to 2. We have now x over 2 as the first product here in this quantity. Next, for the second one, we have 1/6 over 2. 1 over 6 times 2. Just put 1 here and then directly multiply their numerators and denominators. So we have 2 over 6, both divisible by 2. 2 divided by 2 is equal to 1. 6 divided by 2 is equal to 3. Therefore, it gives us the simplified form 1/3. And there we have 1 over 6 times 3x is x over 2. Also, 1 over 6 times 2 is equal to 1/3. So copy positive 1/3. And then write the unaffected term, negative 2x. Combine like terms to each of the sides. We have now 1/3 x. Then we have 2 plus 5 is equal to 7. X over 2 plus 1/3 minus 2x. So now this is a more simplified form than what we have on the first given. But we still have denominators here. We are still in fraction. Now, if we want to make it um, in a form that we can easily solve it, we can just cancel all the denominators of these fractions. How do we cancel these denominators? We must first find the LCD. When we say LCD, it is the least common denominator. So there are lots of numbers that we can see that 3 and 2 meet in terms of their multiplication or multiples, but the first or the least that is common to them in their multiples is 6. So that is their LCD. So what should we do with the LCD of these two numbers? Okay, so we will be using it to cancel all the denominators here. So what we're going to do is to multiply 6 to every term of the given equation. So multiply 6 to every term. That means we need to multiply it one by one. Let's start with 6 times 1/3 x. So I'll be writing it here. 6 times 1/3 x plus 6 times 7. Take note, every term must be multiplied to 6. 6 times x over 2 plus 6 times 1/3, then minus 6 times 2x. Okay, next, let's simplify it one by one. 6 times 1/3 x is equal to 6 over 3, which is equal to 2, then copy x. Plus 6 times 7 is 42, equals 6 times x over 2. So we have 6 divided by 2 is equal to 3, then copy x, we have 3x. Plus 6 times 1/3, so it becomes 6 over 3, which is equal to 2. Then minus 12x. If we want to cancel all the terms here with x so that we have only one side who's having an x, which is the left hand side, we can subtract all the terms with x here. Okay, so what we can do here is to first simplify or combine like terms. Copy 2x plus 42, and then combine 3x and negative 12x. That gives us negative 9x and then plus 2. If we have negative 9x to be cancelled out here, just add 9x to both of the sides. That gives us 11x plus 42 equals negative 9x plus 9x is 0. So plus 2, just copy 2. Now, if we want to cancel out 42 here, what we're going to do is subtract 40 to both of the sides. Subtract 40, so we have 42, should I say? 42 minus 42. Okay, so that gives us 11x equals negative 40. So we can now divide both sides by 11. And therefore, x is equal to negative 40 over 11. This is another conditional linear equation because we have x equals negative 40 over 11. So this would only be the number that makes this equation true. Now let's shift gears completely. So far we've been solving linear equations in one variable, but linear equations can also involve two variables such as x and y, and three variables as well such as x, y, and z, and more. And when they do, we can actually draw them as a picture, a straight line. Let's learn the process. So our target now is to understand how to graph a linear equation. Okay, so the first step is rewrite the equation is slope or in slope intercept form, where y equals mx plus b. This is the form we want to graph. Y is equal to mx plus b. Then next step is to identify the slope m and then the y-intercept b. Step 3, plot the y-intercept form 0, b on the graph. Fourth, from that point, use the slope, rise over run to walk to a second point. If the slope is 2, for example, that means rise is 2 and the run is 1. Next, draw a straight line connecting those 2 points and it extend it in both directions with arrows because the line goes on forever in both directions. There's also a backup method. Choose a few x values, compute the matching y values, plot the points x comma y, then connect them with a straight line. Both methods get you to the same picture. Let's start with example 1, which is y is equal to 2x plus 1. Again, first thing that you must understand is to write the equation in slope-intercept form. However, this given example number 1 is already in the slope-intercept form. Okay, again, the form is y is equal to mx plus b. Okay, so now, second step is to identify the slope and intercept. Slope is represented as m. Therefore, whichever is um, the number with x variable beside it, that is considered as the slope. Therefore, in 2x plus 1, 2 is considered as the slope. And the constant one, or the number without the variable x, is considered as the intercept or the y-intercept. So we have m is equal to 2 and b is equal to 1. Next, we can use the concept of table of values. How do we use the concept of table of values? So remember, we can assign any x values, and then assigning x values would gives us the chance to compute for the y values. For example, if x, let me write it here. If we have y is equal to 2x plus 1 and x is equal to negative 1, so you will be the one to think of the value of x. You can use any value of x here to understand the picture of this linear equation. Y is equal to 2x plus 1 and x is equal to negative 1. Therefore, y is equal to 2 times negative 1 plus 1. That gives us 2 times negative 1 is negative 2 plus 1 equals negative 1. That is the value of y. So we have now x equals negative 1 and the value of y is negative 1. So I'm the one who um, thought of this value, okay, negative 101, but I can also use negative 3 or negative 5, whatever I want to be shown on my graph. So next, how about 0? If x is equal to 0, we'll use the same function. Y is equal to 2x plus 1, so that gives us y is equal to 2, x is 0, so 0 plus 1. Y is equal to 1. That's why we have 0, comma 1. And then we also have 1, comma 3. So we have 1 and 3. If x is equal to 1, therefore we have y is equal to, again, 2x plus 1. Therefore it gives us 2 times 1 plus 1, which is equal to 3. This is now the value of y if x is equal to 1. Therefore we have 1, comma 3. So these are some of the values that we can represent here in this in the graph of this function or in this equation. Now we can continue with the process. We can also use this concept. Start at 0, comma 1, then rise 2, then run 1 to reach 1, comma 3. Okay? So that means, for example, I have a Cartesian plane. This is only an example. 1, 2, 3, 1, 2, 3. Negative 3, negative 2, negative 1, 1, 2, 3. 1, 2, 3, negative 1, negative 2, negative 3. So now, I'll start my graph with the y-intercept. Okay, so again, if we have y is equal to 2x plus 1, for you to find the y-intercept, it can be the point that you want to start with. What you need to do is to substitute x equals 0. So it's a standard process that you can do. So y is equal to 2 times 0 plus 1, that gives us y is equal to 1. But therefore, the first point that you can draw here in the graph is 0, comma 1. So we have 0 for x-axis and then 1 for the y-axis, 0, comma 1. So the y-intercept represents the point that touches the y-axis. That's why it's called the y-intercept. Okay? And then you may consider to rise to, because the slope is 2, rise to 1, 2, and then run. This is y-axis represents rise, and then x-axis represents run. So let me use another color. Rise to, run 1. So this would be the next point. Okay, another. Rise to, run 1. This is another. Rise to, run 1. This is another. Same thing with this. Okay, we can also do that. We have, in this case, if we have rise to, so we can now fall to 1, 2, and then go back 1 here. Fall to, go back 1. So this would be the representation of the graph if we expanded it. So it is an increasing graph. It means that it is diagonal from left to right. Okay, so that is considered increasing. Same thing with this. This is the graph of the given y is equal to x plus 1. Next, graph example 2, 3x plus 2y is equal to 6. Our target here is to first write it as slope-intercept form. So for us to solve it, we must solve for y. The first thing that we must do here is to eliminate all the terms present on the side where y exists. So if we have 3x plus 2y equals 6, we must eliminate 3x here. So subtract 3x both sides. That gives us, cancel this one, 2y is equal to negative 3x and then plus 6. We cannot combine this because they are not like terms. And then divide both sides by 2. Okay, that gives us y is equal to negative 3 over 2x plus 6 over 3 is 6 over 2 is 3. That's why it gives us the slope-intercept form y is equal to negative 3 over 2x plus 3. Therefore, m, or the slope, is negative 3 over 2, and b, or the intercept, is equal to 3. So another technique that we can do here, aside from using the table of values, we can simply identify the intercepts. Again, y-intercepts represent the point that touches the y-axis, while x-intercept is the point where it touches the x-axis. So how to find the y-intercept? Again, to find the y-intercept, Set x equals 0. This is y-intercept. Set x equals 0. So given our slope-intercept form, we have y is equal to negative 3 over 2 times 0 plus 3. So y is equal to 3. Therefore, if x is equal to 0, y is equal to 3. That gives us the point 0, comma 3 for the y-intercept. How about the x-intercept? So to find the x-intercept, we set y is equal to 0 for us to find the point that touches the x-axis. If y is equal to 0, so we have y is equal to negative 3 over 2x plus 3. And y is equal to 0, so we have 0 is equal to negative 3 over 2x plus 3. Okay, we can eliminate this 3 to this side so that x would be isolated. So subtract both sides to negative 3. That gives us negative 3 equals negative 3 over 2x. And then if you want to cancel negative 3 over 2 to make it x only, we can multiply it to 2 over negative 3. So that is just the reciprocal of negative 3 over 2. Now, also the left side. Negative 2 thirds times negative 3 is equal to negative 6 over negative 3 is equal to positive 2. Equals, since we use 2 over negative 3, the reciprocal of negative 3 halves, it's automatically cancelled. And the answer is x equals 2. Okay, therefore, if y is equal to 0 and x is equal to 2, the intercept would be, always read x first, 2, comma 0. Then if we graph it, we have 0, comma 3, 0, comma 3, 1, 2, 3. This is where it is. And 2, comma 0, 1, 2, comma 0, it will not be rising. Therefore, this is where 2, comma 0 is. And then just connect the points. That gives us the picture of the graph of 3x plus 2y equals 6. Let's proceed now to the summary. Let's bring it all together with a quick recap. An equation asserts equality with an equal sign. An expression does not. Equations split into algebraic and transcendental. Algebraic equations split further into polynomial, rational, and radical. Polynomial equations are classified by degree. Linear is degree 1, quadratic is degree 2, cubic is degree 3, and so on and so forth. A linear equation has degree 1, and its graph is always a straight line. It can be increasing or decreasing, depending on the slope. If the slope is positive, therefore it is increasing, and if the slope is negative, therefore it is decreasing. Linear equations may be identity, or it comes in three flavors. Identity, always true for every real number. Conditional, true for one specific value. And inconsistent, never true. And to graph 1, convert it to y equals mx plus b. Plot the y-intercept. Use the slope to find a second point and draw the line. That's a wrap for today. You know how to define a linear equation. Tell it apart from other equation types. Classify it as identity, conditional, or inconsistent. Solve it, even the messy fraction heavy ones, and graph it from scratch. That's a complete toolkit. My suggestion for you, you may go back and resolve problems 3, 4, and 5 on your own without pausing to check my steps. That's the real test of whether it's clicked. If you get stuck, rewind to that section and watch it again. Great work for today. I'll see you in the next lesson. Thank you.